Hi everybody, and welcome to this first video on arrays. This video is an introduction to arrays, and so what I want to do is I want to show you how they're declared, how they work, things like that, and compare and contrast them with vectors, which we are now somewhat comfortable with. So first of all, what is an array? An array is a list. Okay, so just like a vector is a list. So you can store a list of numbers, a list of characters, whatever, you can store those inside of an array. So given that that is what an array is, your first question to me is probably something like this. We already know how to handle lists. We already know how to create a list of numbers or a list of decimals or a list of characters or whatever, right? And we have done that using vectors. So why are we going to use another tool that does the same thing, right? What's the point of introducing a new tool that does the same thing? It's a waste of time. It's redundant. So my response to that question is essentially, how dare you question me and what I'm doing? You know, I am, as a god in this course, a god that is not to be questioned. So that's my first reaction. My second reaction is, okay, that's a good question. And so here's why we're dealing with arrays. Vectors are good for one-dimensional lists. They're sort of built for that. You can use them to store two-dimensional lists or tables, whatever word you want to use, but it's just not quite as user-friendly as arrays. Arrays are really good for two-dimensional lists such as tables or matrices, whatever you want to call them, or three-dimensional lists or higher dimensional lists. So that's why we're going to use arrays now. So we've been dealing with one-dimensional lists for a while. Now let's go on to dealing with things like tables and matrices, and arrays are good for that. So that's why we're introducing a tool that basically does the same thing. It does the same thing, but it's good at doing it in different contexts. So if you want to declare an array, here's how you do it. You just tell it what kind of array you want. So tell it integer or float or character or whatever. You give it a name, and you must give it a size. Okay, that's in contrast to vectors, where you didn't necessarily have to give it a size. With arrays, you must give it a size. So there are three things to declaring array: the data type, the name, and the size. In contrast with vector, you actually don't have to write, bracket array right here. Array is a built-in thing into C++. You don't have to have a hashtag include array library or anything like that. So when you write something like this, the computer knows already it's an array. You don't have to tell it that. So to declare an integer array with 10 entries, this is just how you do it. So I'm going to have a list of size 10, and what's inside the list are integers. You can initialize arrays if you want to. This is in contrast to vectors where we never did this, but here's a string array, right, with 4 entries. And so, you can say these 4 strings in there, and now the array is initialized. A lot of times you don't do that because with humongous arrays, you don't want to write everything out. So if you have an array that's bigger than size 6 or something, it's better to use a loop to give it values rather than to initialize it like this. Okay, like vectors, you can access individual entries inside of the list using the square bracket notation. So this thing right here stands for the entry of my list, the entry of my array at position I. So I is giving the position, and then when you do my array bracket I, you're getting the entry at that position. So like vectors, the first position is position 0. So C++ pretty much always starts counting as 0. And the last position is the size of the vector, take away 1, because you don't want to count too far. So here's just an example of using an array. This is a string array with 3 entries. So you can ask them, what are your favorite hobbies, right? And then press enter after each of them. So this for loop will run 3 times, and each time it runs, you get a hobby from them. So when I is 0, you save the first hobby in hobbies bracket 0. When I is 1, you save the second hobby in hobbies bracket 1. And when I is 2, you save the third hobby in hobbies bracket 2. Okay, so again, so far there's not really a ton of difference between what we've done with vectors and what's going on now. Right? This is basically the same. Okay, so here is one of the main differences between vectors and arrays. The size of an array cannot change. Once you've declared an array and given it a size, you cannot resize anything. This is in stark contrast to vectors, whose size can change, right? For example, you can use pushback and popback. Those things either increase or decrease the size of the vector. So this is a disadvantage of arrays, right? That means they're not as powerful as vectors. So their size is constant. You can't change the size. So for example, consider these two lines of code. You set size equal to 5, and then you declare an array of size 5. That's fine, but later in the code, if you now write size equals 7 or something, or size equals 2, if you change the value of this variable size, chaos ensues. Okay, so different compilers will handle it differently, but essentially you just never want to change the size of an array. So don't do it. They're not like vectors in that sense. Okay, so now let's get to the heart, or part of the heart, of why we're talking about arrays. So let's talk about two-dimensional arrays. Oh, and I guess I should mention here that we're not talking about arrays just because they're good for higher dimensional lists. For those of you who go into engineering or programming in your own field, arrays are more prevalent in practice than vectors because arrays are older. So you will come across more arrays than vectors when you look at old code. So it's good to be familiar with them for that reason also. Okay, so let's now talk about two-dimensional arrays, which are, you can use the word matrix if you want to, you can use the word table if you want to, but that's what they are. They're tables. So you have sort of one-dimensional lists stacked on top of each other. Here's how you declare a two-dimensional array. You tell it what kind of data type the entries are, you give it a name, and now since it's two-dimensional, you have to tell it the number of rows you want and the number of columns you want. So here's an array with three rows and 4 columns, and the entries will be integers. So a picture of what that will look like is this. You have 3 rows and 4 columns, and again, C++ starts counting at 0, so the first position up here in the upper left-hand corner is not position 1, 1, which you might think it would be. It's position 0, 0. So as opposed to a one-dimensional list, inside of a two-dimensional list, you need 2 pieces of information to specify where you are. That's why these subscripts have 2 numbers. This is entry 0, 0, top left. This is entry 0, 1, close to top left, but you've taken 1 step to the right. 0, 2, you're in the same row as top left, but now you've taken 2 steps to the right, and so on. So the first number in the subscript keeps track of what row you're in, and the second number keeps track of what column you are in. So this right here, 2, 1, means you are in the second row, first column, where again you start counting from 0, which is confusing, right? Because really this is 1, 2, 3. This is row 3, isn't it? You know, but the computer does 0, 1, 2, second row, right? 0, 1, first column. Right, so this is one of the many things that takes getting used to when you're dealing with two-dimensional arrays. But anyway, if you declare something like this, this is what it looks like to the computer. It's a table with 3 rows and 4 columns. Okay, so here's a bigger array, and this is showing you the index positions here. So this is position 0, 0. The entry at position 0, 0 is 1. The entry at position 0, 1 is 2, and so on. The entry at position 5, 7, so row 5, column 7, that entry is 58. Okay, so if you have a two-dimensional array and you want to access individual entries of that array, you have to tell it which row and which column to look in. So this is in contrast to like this, okay? When you have a one-dimensional list, you only have to give it one position to know where you're supposed to look, right? So you're telling it the hobby at position 1 or the hobby at position 2. You only have to hand the array one number and it knows what you're talking about. But in a two-dimensional array, right, suppose I hand it the number 5. So I say, hey, find me my array, bracket 5. The computer goes, well, I don't know what you mean because row 5 has several entries in it, right? So if you just give it a single number, like, hey, find me the entry at position 5, the computer doesn't know what you're talking about. But if you say, hey, find me the entry at position 5, 7, so in row 5, column 7, now it does know what you're talking about. It finds the intersection of row 5 and row 7, and it picks off this 58. Okay, so I should state up front that this takes getting used to. This notation, what everything is telling you, that takes getting used to. Okay, so you're just going to have to practice with this to get comfortable with it. Those of you who have had linear algebra will be more comfortable with this because you've spent a lot of times manipulating matrices. But even those of you who've had linear algebra, this takes getting used to. So here's a question for you. I just have this array sitting here, right? This is a table. It's 10 by 10, 10 rows, 10 columns. How would you create this in C++? Well, first of all, you have to declare the array, and it has 10 rows and 10 columns. So you declare that. And this is another thing that takes getting used to, but if you want to work with a two-dimensional array, you're going to have a nested for loop almost always. This outer for loop is dealing with the row number. So it goes from I equals 0 to I equals 9, right? It stops at 10. That's going to deal with the rows. The rows go from 0 to 9. This inner for loop is going to deal with the columns, which also go from 0 to 9. So let's talk about what's happening right here. Before we focus on the formula here, let's just talk through the logic of where I got this from. Suppose somebody says, okay, I want you to write a formula to save this array in C++, right? You might notice a pattern. I mean, you immediately notice a pattern. Row 3, right? All of the entries start with a 3. 3-1, 3-2, 3-3, etc. Row 5, all of the entries start with a 5. 5-1, 5-2, etc. So basically, to create the number 51, it seems like what you should do is do 5 times 10 to get you up to 50, plus 0 plus 1. Same thing with like 61, right? You can do 6 times 10, get you to 60, and now take the 0 and increase it by 1 to get you 61. Or like the 76 right here, right? You can do 7, so row 7, you can do 7 times 10, plus the column number, which is 6, plus 1 is 77. Or sorry, I guess I was at 76, right? So 7 times 10 is 70, plus 5, plus 1 gives you 76. So that's what this formula here is saying. It's saying, hey, you want to know what entry is at this position, at position ij? Well, just take 10 times your row number, add the column number, and then add one more. And that's what it will do for you. So what's going to happen is this outer loop is going to run 10 times. Every time this outer loop runs, the inner loop will run 10 times. And so when I is 0, so think about fixing I equals 0. Now you go inside of the outer for loop. Now this inner for loop will run 10 times. And I is 0 the entire time. So I is 0, so you have 0 right here. And then j runs from 0 to 9. So you have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on up to 0, 9. And then this for loop here stops. Now you reach this brace down here, and now you increase the value of I by 1. So now I is 1. So the next time you do this inner for loop, right here, I is 1 every time. So you're going to do 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and so on up to 1, 9. So basically, every pass through this outer for loop creates a new row, row I. Okay, so when I is fixed, when this little I value is fixed, this inner loop creates the row at row I. And so again, especially if you're not used to dealing with matrices, this can be confusing. Okay, a nested for loop where you're initializing a table, or sorry, you're giving a table all of its values, etc., can be confusing. So make sure that you understand why this nested for loop structure gives you this table. Okay, if you don't understand that, you're not going to have a good starting point for dealing with these arrays yourself. So make sure you can visualize this. Think about when I is 0, what happens? Oh yeah, this inner for loop creates row 0, right? And it uses this formula where I is 0. Oh, and then I becomes 1. Then this inner for loop creates row 1, where I is 1 all the time, and you use this formula, etc. You need to dynamically see this happening in your head. Okay, Once you have a 2D array, how do you print it? Well, you're going to have to use a nested for loop again. So what this for loop here does is, it does essentially what we did before, except now you're going to print out the entry at a given row, at a given place, and then you're going to see out a new line in between each row. So let's think about what happens when I is 0. When I is 0, you go into the loop, and now you do this for loop 10 times, and I is 0 every time. And you print a space in between each entry. Once this loop is done running, you print a new line. Then the value of I increases by 1, and you just start over. And so now I will be 1 in here. Okay, so let's actually do this in the compiler and make sure it does what I'm claiming it does. So let's create int my array 10, 10, and let's do this nested for loop. So the rows are going to run from 0 to 9, as are the columns. So J is going to run from 0 to 9 also. And now we're going to give each entry in the table a value, and it's going to be based on this formula: 10 times the row value plus the column value plus 1. Now let's print this guy. So we're going to, again, if you want to print, maybe let me just copy and paste this. So now if you want to print, you should just print the entry at that spot. And inside of a row, right, this inner for loop here, this J for loop, is printing row entries. So you want a space or 2 in between each row entry. But once you're done with that inner for loop, you want to now put a new line in between each row. So let's run this and see what happens. And it prints that table, right? It doesn't print it in a particularly nice way. It's not aligned properly, but here you go. At least we know that it saved the entries that we thought it saved. So you can play with this all you want. I mean, you can, like, if you really want to see what's happening, you should take this code and tweak. So, like, what if I change the formula from 10 times I plus 1, right? That's what was there. What if I take that plus 1 away? What's that going to do to this table when I run it again? So let's talk through what that does, right? This for loop, this nested, these two nested for loops create the array in the first place. So when I is 0, this inner for loop creates row 0. So when I is 0, 10 times 0 is 0, right? And J runs from 0 to 9. So now this first row actually won't be 1 through 10. It should be 0 through 9, right? Because J runs from 0 through 9. And etc. for the rest of the table. Right? So it's basically the same table except you took away the plus 1. So all of the entries now are 1 less. Or think about, let me change the number of columns to 8. So now the number of columns runs from 0 to 7. From 0 to 7. Right? So once you hit 8, you stop. What would that print out? Well, essentially all I did was I took this table here, this big table, and I truncated the last 2 rows. So it should print out what I have right now, except the last 2 rows are gone. I'm sorry, the last 2 columns are gone. And that's what happened, right? So it used to, let's change this back. It used to go up to like 18, 19, right, in that second row. Right, but now it doesn't. So it just lopped off this last column here and the second to last column here. Okay, so again, let me just state one more time. This takes getting used to. Students in previous semesters have had a lot of trouble with this because the notation is kind of confusing if you're not used to it, right? Okay, now I have to keep track of 2 different positions, and then I have to interpret what this means. And again, this means the entry in the table at position ij. So I have to keep track of all of that, and then on top of that I have nested for loops all over the place, right? It's just sort of confusing until you deal with it yourself several times. So in the next video we will move on to formatting the output here. I mean, how do you make it look more aesthetically pleasing than this? And we will move on to higher dimensional arrays and look at more examples.